Okay. Yeah, on the camera, please, all of us. Okay. So let's start the student session. Okay. We already waste 8 minutes. Okay. And I think those who are really interested, they are carry pen and paper and try to collect the data that what I mentioned in the board. Okay. So let's start. Okay, I have one question to all of us that two class are already done from my side, and I ask one question to all of us. I know those who know this answer, you raise your hand and then speak. Okay, so my first question for all of us is, please give me one microcontroller name which is used in Cubsat. Please give one microcontroller name which is used in Cubsat. Anyone? Yeah. Ali Muhammad. Yeah, you say.
Arduino. There's Cubsat, ArduSat. Use Arduino.
Yeah. Perfect. It's Arduino. Arduino Uno. Arduino. Arduino Uno. It's called Arduino Uno. Okay. Really great. Ali Muhammad, you take the right answer. And my second question is, which is the most popular antenna is used in Cubesat? I just draw some. Yeah, Ali Muhammad, only one participant. Yeah.
Yeah. Shall I answer or wait another one?
Yeah, no. You
yeah. Okay. Answer. Patch antenna and tensile antenna.
Perfect. This antenna is very most popular. That I already told that this antenna is really most popular and it is really useful. Okay, good. I think only one student can learn very properly. Those who are not properly, I telling to all of us, please understand. And if any doubt, say, ask to me. My contact numbers is also there. You contact with me also. Okay. But if you have any doubts, don't skip. Okay. Okay. So this is the basic diagram of Cubesat. Okay. And it is a 10 centimeter into 10 centimeter Cubesat. Okay. It is a 10 centimeter into 10 centimeter Cubesat. And just I draw also one thing. In the Cubesat, okay, in the Cubesat, there have three layers. In this layer, the lower part is battery. Okay, the lower part is battery, and the second part is this is the fourth part. Okay, this is the fourth part. The third part is like the electrical signal. Okay, and then the second part is most of their in this second part mainly the camera is also there. Okay, camera and also some other equipments like GPS and sensor. Okay, so camera, GPS and sensor is most probably used in the second layer. Okay, and the first layer is mainly most important, which is use the deployment section of the antenna. Deployment section of antenna. Okay, this is the most important part, which is used in our satellite. First one is battery section, third is electronics, second is camera, GPS, sensor and other electronics equipments. Then number one is deployment of antenna section. What is the deployment of antenna section? What is the deployment? Deployment means when a CubeSat reach to the space, this time the antenna is folded. Okay, these are the antennas. Okay, these are the antennas, different types of antennas. As example, I taking one antenna image. One antenna, just wait. I taking one antenna. Okay. As example, it is our antenna. As example, it is our antenna, and in the antenna, it's folded. Okay, it's folded. Folded means it's like that. It's like that. Okay, it's like that. It's folded, and when the satellite reach, this is the top part. I mean, this is the upper part of the satellite. It is the upper part. It is a number one part of the satellite. It is a number one part of the satellite. Okay. When it reach to the space, this time it's open. Before reaching the space, it's not open. Okay. When it's reached to the space, then it's open. It's called the deployment section of the antenna. It's called the deployment section of the antenna. Okay. Everyone understood? It's called.
Can I say something? I think the lower parts, number 4 and 3, it's called electric power system, right? EPS.
Yeah.
Usually take a board with the connected part.
That in this CubeSat, these are the layers, and in this layer we have different section, and in the different section we have different microcontroller boards, batteries, sensors, GPS modules, and also the solar panels is attached in the structure of the body. Okay, and generally in the CubeSat the voltage is approximate 12 volt to 24 volt. Okay, the voltage is approx 12 volt to 24 volt. This is the basic voltage for charging the CubeSat. Okay, and this voltage is depend according to the CubeSat size. The mainly for the 1U CubeSat, the voltage is generally 5 volt to 9 volt. The voltage of the solar panels is generally 5 volt to 9 volt. If the CubeSat size is increased when it goes to the 2U satellite, like these types of satellite, then we use the voltage is approx 12 volt. Okay, the generally voltage is approx 9 to 12 volt. 12 volt to 9 volt. Okay, so this is the basic difference. It is really important for the solar panel voltage, because if we send the satellite to the space, when it reach to the space, it need the charging system, right? So for the charging system we use the solar, and in the solar system there have different size. According to the different size, we need different solar panel voltage. For 1U we need 5 to 9 volt for charging the battery. For 2U we need 12 volt to 9 volt. Okay, 9 volt to 12 volt. So this is the basic important parts of the Cubsat. Now we are going to the next part, which is the signal and data transmission process. Okay. So now we are discuss the data transmission process, and also the code work and what types of coding language we are using for development these types of communication system. Because when we use the hardware, we need the software side by side, right? So according to this, if we use the hardware, we need the software. So just wait. Now I draw one hardware that Ali Mohammed is already said to everyone that the Arduino is basically used in here. Okay. So now I am telling the advanced module, which is Raspberry Pi. Ali Mohammed, you know about the Raspberry Pi? It's a most popular and very very powerful device. It's called a Raspberry Pi, and it's really a strong memory and also a good frequency and also a good capacity. There have lots of GPIO pins is there, and it connected with lots of sensor and modules. You know about this, Ali Muhammad? And
Yes.
yeah, it's really great. Okay, for the big satellite, for the most advanced satellites, the generally the 90% Raspberry Pi is used. For some kinds, for some satellites, the companies build his own PCB on motherboard for his satellite. Okay. So now I am discuss right now the data communication system between the satellite and the computer. Okay. So as an example, this is our computer, and this computer, okay. So this is our computer, and this computer send the data, send send data to the satellite. Okay, send data to the satellite. Okay, so this is our satellite and this is our computer. Okay, so computer send the data to the satellite in, okay. So here you see that it's our computer computer, and it send the data to the satellite. Okay, and in the another side, satellite send the data to the computer. Satellite send the data to the computer, and this system is continuously moving. This system is continuously rotate in 24 into 7. Okay, this system is continuously going on in 24 into 7, and the satellite getting the energy, getting the resource, getting the electricity from the sun. Okay, so now we are discuss about how the data is transmission, how the data is connected. Okay, so here we have a radio frequency. This means the RF, radio frequency. I think everyone know about the radio frequency. So in the radio frequency, the antennas are receive and transmit the data through the RF, and the computer, before coming to the computer, one device is connected to the computer. It's called the multiplexer. It's called the multiplexer. It's called the multiplexer. The RF data coming to the multiplexer, and multiplexer after the encode and decode, the data is goes to the computer, because multiplexer take lots of output, and multiplexer produce multiplexer take lots of input and provide one output. It means that if we get lots of data packets, data is called also a packets. Okay, so when the computer gets lots of data packet, then the multiplexer help to sort out and getting the one data signal output to the computer. Okay, so here you see there have lots of data is coming, and the multiplexer provide the one output. Okay, getting the one output signal to the computer, Okay, so this is the circle that RF send the data to the multiplexer. Multiplexer provide the one signal output, and this signal goes to the computer. Then computer coding like Python, most probably Python are used. Python analysis the data, and then the Python provide the data like temperature, pressure, humidity, and also the sunset. Everyone try to on your camera please for more understanding. Okay, so now we are discussed about the next topic, which is very interesting and very wonderful, which is our electronics embedded system part, and also the coding part, and also coding with the hardware combination system. Okay, so now we are discuss about the hardware and software combination. Okay, so first we learning what is the hardware part and what is the software part. I think everyone know about what is the hardware part and what is the software part. In hardware part, we have, like as I already told that in hardware part, there have different hardwares like Raspberry Pi, Arduino Uno, ESP8266. There have lots of microcontrollers is also there. It's called the hardware part. And in the software part, we are like the software like the Python language, like the frequency code, like the encode, like decode. These are also used in the software part. Okay, I think it's clear to everyone. Any doubt? Yeah, integrated circuits. Any doubts? Clear? Any doubts to all of us? Okay. Okay. So we are moved to the next part, which is our uh, okay. If any doubt, we are moving the next part. If anyone have any doubt, please ask me. We are not come back. Okay. If it's totally complete, we are go to the next part. If anyone have any doubt, I already repeat to all of us. If anyone have any doubt, ask first. Yeah, ask. Asked and try to on your camera, please.
Um, should I learn a programming language that cannot build Cubesat, like as Python or anything language?
Basically, for the model of the CubeSat, okay. For the model of the CubeSat, you know the C++ language. Okay, you know the C++ language. The C++ language and also the C language is most commonly used in the coding part of the microcontroller. And for the Raspberry Pi, we have another software which is Raspberry Pi PI. Raspberry Pi PI software which is used for the Raspberry Pi. Okay, so these are the different languages that are using in the software, hardware, and it's depend on the hardware. If hardware is different, the software is different. Okay, it's need according to your need. Okay, it's depend according to your need.
Okay, thank you.
Okay. Okay, one student is on his camera. Okay, good. Okay, so now we are talking about is a most uh, tough and hard topic, which is the satellite link up. Okay, the topic is satellite link up. So what is a satellite link up? Okay, you see there have one satellite, it's called one. In another, it's called satellite 2. Okay, so I draw these different types of satellite. Okay, I draw different types of satellite, and it says it's all are 2U satellite. All are 2U satellite. Okay, so when these all satellites are moving in the orbit, approx the 2U satellite in 200 kilo, 280 kilometers. In the 280 kilometer, the satellites are moving. Which satellite? The 2U satellite. Okay. In the 280 kilometer, the satellite are moving, which is the 2U satellite. So when it's moving in the 280 kilometer of the Earth surface of the orbit, this time the satellites is trying to connect. We can easy to connect with one satellite to the another satellite. It's called the satellite link up. I mean that one satellite interconnect with the another satellite. As example, this satellite connected with this and this satellite connected with this. Okay, these 1 and 3 connected with each other. 1 and 3 and 3 and 1. Both are connected with each other. If it's called a single link up. Okay, when it is connected with multiple satellite, it's called the multiple link up satellite. Okay, it's called the multiple satellite link up. When it is connected with the multiple satellite. Here you see we have 3 satellite and 3 satellite connected with each other. The 2 is connected with 1, 1 is connected with 3, and another 3 is connected with 2, 2 is connected with 1. Okay, each and every one is connected with each other, and they are produce a single output. They are produce a single output. So here we know about the multiplexer, because here we getting lots of data, and these data are complex, and the multiplexer can taking all the data and send the one output. Okay, and generally the CubeSat, and when the satellite is really more, it's called the space junk. We know about that. It's called the space junk. When satellite is destroyed, it's called space junk. So when satellite is old and its working power is low, this time scientists start work this technology for getting more accuracy data of the orbit. Okay. Okay. Everyone understood? Any doubt? Any doubt? Everyone?
I have a question.
Yeah.
Is it possible if we connect more than 2 satellites, like 3 and more? It's okay, right?
3, 1U and 2U.
No, I mean like if we added another satellite, like a third one, is it possible?
You can add up to 100 to 200 satellite. Okay.
Oh, okay.
That's as example when we add.
The prediction.
Yeah. Yeah, please say. Okay. So we can add a lots of satellite. Okay. 1 to approx 200 satellite we can connect in one time. Okay, and it's provide a one single output, because when we use a lots of satellite, it's provide a good accuracy data, right? So it's really good for use. Okay. The 25 participant is there, and who are really enjoy this session, please really raise your hand. I want to check it. Those who are enjoying this session, please raise your hand. I just want to check it. Okay. Lots of people are raised his hand. Okay. Great. Thank you so much. All of us, thank you.
A question in the message box. Someone's asking a question.
Yeah. Okay. So our next topic year goes of our I think we cover lots of part, and the electronics part is also covered, the hardware coding parts is also covered, and I think the most important is the okay, I already talking about the structure. I think it's covered, right? Structure is covered or not?
Yes. Yeah.
Okay, structure is covered, right? Okay. Okay. Now I think it is the more basic things of development the satellite. I think it's over totally, and we cover the all of parts. Now the main thing. Now it is a very important. I think everyone try to record this session. Okay. Now I share with all of us that how you make one satellite at your home. I think it is a most popular session that and topic that how you make you one you Cubesat at your home, and no one can give you this suggestion and this technology for development to manufacturing a satellite at your home with your home equipments. By your home equipments, how you build a satellite. Okay, I think everyone ready for learning how you build the satellite at home by your home equipments. Okay, those who are like this session, those who are interested like this session. Okay, so okay, now everyone note down in your notepad. Okay, first I give one component list. Okay, you just purchase from your nearest shop. All and also Amazon is also there. You can purchase through the Amazon. Okay, and buy your nearest shop. Choice is your. Yes. Tell me.
Go ahead, Mr. Salah.
Okay. So first you write the component name. The number one is a very common item, which is a pencil. I think everyone is available in everywhere, in every market, in every location. Okay. You uh, purchase two packets of pencil. Two packets of pencil. Number one, two packet
Go ahead,
of
Astronomer Salah. Go ahead.
pencil. The second, okay. The second, okay. I think it's not visible. Okay, no problem. Okay. The second is after pencil, you carry two 3.7 volt lithium ion battery. Two 3.7 volt lithium ion battery. Two 3.7 volt LiION. You carry two 3.7 volt lithium ion battery. The third one is ESP8266. ES sorry ESP8266 module. ESP8266 module. Okay. ESP8266 module. Okay, and the fourth one is jumper wire. Jumper wire, male, female.
Sorry.
Yeah.
Someone is asking. Someone's asking for the first one. 2 buckets of pencil. I think they need to write it down.
Yeah. 2 packets of pencil. First one is 2 packets of pencil. Second one is 3.7 volt lithium-ion battery. Third one is ESP8266 module, and fourth one is jumper wire. JUMPER. Jumper wire. Jumper wire. Okay, jumper wire. Okay. Fifth one is the sensor, like a temperature sensor, T sensor, temperature sensor. Also, temperature sensor also. Okay, temperature sensor. Sixth one is GPS module. GPS module Arduino. When you search in Google, you search GPS module for Arduino. Seven is the B-type charger cable. B-type charger cable. Eight is glue gun and glue gun stick. Okay, glue gun. I think everyone know about glue gun and glue gun stick.
Excuse me, can you explain the number 5?
Sensor, temperature sensor.
Okay.
Temperature sensor, GPS module, B-type charger, glue stick and glue gun. Okay.
What is the blue gun? Glue gun.
You search on Google. Glue stick and glue gun.
Okay.
The 9 number points is the
Communication system.
the gyroscopic module. Okay, write the gyroscope module. Gyroscope. And also one power bank module. Okay, it's really important. You write with the 3.7 volt battery in the second point. You write with the 3.7 volt battery with uh, with power bank module.
And communication system.
Okay, you write on the second point, add with power bank module, because power bank module is connected with the two lithium-ion batteries for getting the voltage power supply to the ESP8266 module.
I think number 3 is the communication system. Number 3. The Wi-Fi communication system.
Yeah. It's ESP8266. Just wait. I just shared the ESP. Okay. This is the ESP8266. Okay. The price is approx 194 INR. Okay. You convert in your currency, it's 294 INR. So 294 INR convert 294 INR to EGY, Egyptian pound. Okay, convert to it Egypt pound. Okay, just wait. Okay, the price is approx Egyptian pound 159.63. Okay, Egyptian pound. Okay, the approximate cost of the total system is making cost from INR is approx 2,500 max. 2,500 in Egyptian pound is rupees 1,357.41.
Is it when we purchasing the whole thing? Like when we're making it at home?
Yeah. It's built on Indian rupees to 2,500. Okay, and it max if you use the GPS cost is high. The approx cost is 1,000. Then it goes to the 350 INR, 3,500 INR, and it goes in Egyptian pound is rupees 1,900. Approx you taking, if we increase 6, then sorry is 7, then is approx you 2,000. Approx in the 2,000 Egyptian pound it totally complete your satellite. A home satellite is totally complete by 2,000 Egyptian pound. Okay. And the another is our, which is the GPS module. Share the tab inside GPS module Arduino. GPS module Arduino. Okay. GPS module Arduino price. Okay. Its cost is approx in RoboU 230. Okay, it's very low, not high. Sorry, it's my mistake. Is very low, 230. NEO6M GPS module. Okay, NEO you write NEO6M GPS module. NEO6M. I repeat, NEO6M GPS module. NEO6M GPS module. Okay. And temperature sensor Arduino. Okay, it's called the DHT11 module. DHT11 module. Okay, you write DHT11 module. This is the module DHT11. You see, this is the module DHT11. This is the module. Okay, this is the temperature module. Code is DHT11. Okay, and the also the power bank module. power bank module is approx 249. Okay, you can purchase any one, you can purchase these, you can purchase this, you can purchase any one, is very low cost. Okay, you can purchase any one, and connection like a parallel connection, make it parallel connection. Okay, not series. Okay, it's required the voltage 3.7 only. Okay, not make it 6. I think everyone know the parallel circuit and the oh, series circuit. Okay, you read from learning from the Google about the parallel circuit and the series circuit. Okay, of the battery connection. In this module, we need a parallel connection, only 3.7 volt. Okay. Okay. I think all is clear. Okay, one thing, jumper wire. Just wait. Jumper, jumper wire. This is a jumper wire. Okay, you purchase different male, female, female, male, female, female, male, and male, male. You purchase different types of jumper wires. Okay. This. Okay, this is the jumper wire. Male to female. Yeah, I think here the most need is the female to female. Okay, you purchase female to female, and another is female to male. Okay, female to male and male to male, female to female and male to female. You purchase both. Okay. Okay.
What is the female to male?
You search. You see that here one that is female to male, another is male to male, another is female to female.
Talking about the jumper, right?
It's called the jumper wire. Okay. So the ending time of the session, okay, is closed now. I think we are spent a lots of time and we are learning lots of technology, lots of system, and today's class, the super master class of the Cubsat. I think the whole part is covered, and also how you making the Cubsat at home. Okay. The next session is conducted by our a special person which name is Anirban. Okay. The next class is after 2 to 3 days later. Okay. At the time of 10 p.m. Indian time. Okay. And the time is fixed because this day the Anirban take the session. Okay. Of this, and he show you that how you build a Cubesat at home, because he already built up a satellite at home. Okay, and he suggests you and show how you making the satellite. Okay.